Hello everyone. Today we're going to check how to find the resultant force of two other forces. A force is an action upon an object resulting into the movement of this object. It defines the interaction between those two objects colliding together. The force is a quantity that is measured using the standard metric unit known as the Newton. And as an example, we have a force named here B. The force is like a vector quantity, and this vector quantity is equals to 50 newtons here. Usually the vectors are represented proportionally to their quantity. So the length of the vector defines the quantity of the force. We also need to take in account the direction of the vector. So here it is from left to right, as well as the sense. So it is going horizontally right here because the head here of the vector is going onto the right. It is going horizontal, and here is the tail, the other point. So we need to place this force somewhere. Well, we're going to name an object E right here. And this object E is going to be the object that is going to move or not. But right here, since the object E doesn't have any applied force, we're going to say that it is stationary. Here, in the first case, we have a vector that is representing the force A that is equals to 40 Newton. Well, the quantity of the force is equal to 40 Newton. Therefore, the object will have a resultant force right here, and since we only have one force going on the object, we will say that the resultant force is equals to the force A. Therefore, the quantity of the resultant force is equals to the force A. Therefore, the quantity of the resultant force will be exactly equal as the quantity of the vector A, which is 40 Newton. Since this object is starting to move, it is moving right now, we will say that this is an acceleration. The object is accelerating because the resultant force is not zero. In this second case, we have two forces acting. We have the force A going from left to right, and the force B going from right to left, so the opposite direction. These two vectors are linear. They are on the same line. Therefore, we can calculate easily the resultant force without any law. The resultant force is equals to A plus B, but this equation does not consider the quantity itself, it considers the vectors. To calculate the quantity of the resultant force, we need to consider the fact that the vector B is in the opposite direction of the A. Therefore, the quantity of the resultant force is equal to the quantity of the vector B minus the quantity of the vector A, which is equals to 0. So the resultant force is equals to 0. Therefore, we can say it is stationary. In this third case, we have a vector B that is also opposite to the vector A. But this time, the force B is superior to the force A because its quantity is superior. We can already see that the resultant force will go in the direction of the B, but the equation is still the same. The resultant force is still the addition of the two vectors. But here, since the quantity of the force B is higher than the force of the vector A, we will say that the resultant force is equals to the quantity of the force B minus the quantity of the vector A, which is equals to 20 Newton. Even though the resultant force is going from right to left, we are going to call this an acceleration. It is still accelerating. It is still going from a point to another. The direction is just not the same as the two first cases, but it is still accelerating. And the acceleration is horizontal since every other vector was horizontal. And in this final case, the fourth, we have two vectors that are still linear, but they are going in the same way. They are going from left to right. Their direction is the same. The sense is also the same. So it will be easier for us to represent the resultant force. The equation is still the same. It will always be A plus B. But now we can more easily calculate the resultant force because it is just the quantity of both vectors added to each other, which is equal to 60 Newton. And since the resultant force is not zero, we will have an acceleration. We can also represent the resultant force like this. Since the direction and the sense is the same, we can represent it in practically any ways we need or want. We just need it to touch the object in a logical way. We can conclude some stuff from this. If a stationary object experiences a resultant force that is equals to zero, therefore it will remain stationary. For example, if you're not moving and nothing pushes you, you're not going to move, right? This is the same thing, almost. If a stationary object experiences a resultant force that is not equals to zero, then it will accelerate. If you're not moving and that you receive a resultant force, of course you're going to move. Something out of you is going to move, your arm or something, I don't know, but something is going to accelerate. If a moving object experiences a resultant force of zero, it will continue moving. If you're already moving and you experience nothing, then you will still move, right? If a moving object experiences a resultant force that is not equals to zero, then it will accelerate. It will accelerate in the direction of the resultant force. And for the three last sentences, it will accelerate or continue moving in the direction of the resultant force. It will always go in the sense and the direction of the resultant force, always. So we saw how to calculate and determine the resultant force of linear vectors. Now we're going to see for non-linear vectors. There is two laws that you need to learn. So right here, I transform the object into a point that is named A, and I have two vectors, F1 and F2, with F1 equal 100 Newton and F2 equals to 80 Newton. So the laws that we're going to see allows us to determine the resultant force. Right here, we are going to take the first vector, F1, and using the parallelogram law, we're going to determine another segment here that is parallelogram to F1. It will start from the head of the other vector. Keep in mind that it needs to be parallel. Then we're going to do the same thing with the other vector. We're going to take this vector and construct a parallel line at the head of the other vector. So here you have your two parallel lines, and you can see that there is an intersection right here. This is going to be the head of the resultant force. And voila, you created your resultant force out of the two forces. Now let's move on to the triangle law. The triangle law is pretty similar, but this time we're going to take directly the other vector. So this vector right here is strictly equals to this vector, except for the position. So the direction, the sense, the length will be exactly the same for here and here. And this creates an even easier way to calculate the resultant force, which is right here, because this is the addition of the two vectors. We also can find ways to calculate the actual quantity of the resultant force, but I won't go as deep as this, since this requires measurements and could not be very precise. But if I had to say, it would be around 110 newtons maybe? I'm not sure, but there are ways to calculate this. Why is everything that I just presented you important? Why is it important to learn how vector works and how forces works? Well, for engineering classes, it is very important to learn this, since a lot of manipulation with the objects is based around moving and, touching objects together. But It is also very useful in common life for personal utility. It allows you to represent the world around you in your own head. Some people are capable of this, and learning the vectors is just easier for you to learn how to do that. But it is also useful to understand the media of the common days, such as, for example, these graphics that you see at the TV to learn how anticyclones work, or even in video games that you're playing in your own time. I would like to thank you for watching this video, and I hope I have been able to make you learn something today.